Good morning, my dear students. Welcome to this session on two hinged arches which are parabolic in nature. We have solved an example in the last session. That is what is now you are looking at. A parabolic arch applied by a point load at the crown. Right. This is what is being solved in the last class. Okay. So the value of horizontal thrust that you got is 25 PL by 128 H. Okay, let's go for the next example. And even it is one of the JNTUK examination question. So it appeared in November 17. Okay, straight away we take up that as an example. Right, so let us see what is the given question. So you need to calculate horizontal thrust in a two-hinged parabolic arch subjected to UDL on its total horizontal span. That is a given problem. Okay, so span is L, rise is H, and it is parabolic. The load is W per meter. Okay, so you start working from the horizontal thrust equation. So straight away parabolic form of equation where it is suitable for parabolic nature. So modified equation is integral m square y dx divided by integral y square dx. Okay, this is the equation. So now you evaluate the terms to be substituted into the equation. What are all required? You need m dash and you need y. Okay. So how do you get m dash value? It is again similar to the earlier discussion. So take a beam of same load, same span. Okay, right. Let it be like this. So it is W per meter. Okay. Right. So the section is taken here. X. Okay. So at a distance of X. Right. So this reaction you require for writing mx equation. So what is total load? W into L. What will be this reaction? WL by 2. Total load divided by 2. Half of the value. Because it is symmetric, right? So now you write moment at section X. Sum of all moments to the left of the section. So m dash value to write. So first taking reaction, WL by 2 is the load. Distance is X. So WL by 2 into X. Okay. Which is positive. Reason? Clockwise. Left clockwise. Now this is going to create a clockwise moment. Okay. Right. Then what the other load that is to be taken up? It is UDL present to the left of the section, right? What is the load value? W, and the total load is W into X that will act at the center of X. So this is X by 2. Okay, let me erase that extra line appeared. Okay, right. So maybe it has interacted with the other line, that's why it is right. So X by 2 is the distance, and this value of load is W into X, W into the span. Okay. Right, W into X by 2 is moment from UDL. The direction it is going to cause anti-clockwise. So left anti-clockwise, negative. Okay. So what is Y? 4hx into L minus x by L square, parabolic relation. Okay. Right. Substitute those two into this equation. This is m dash y dx. And you can see now either you can work out from 0 to L by 2, make it twice, or you can go for straight away 0 to L also. No problem. Okay, right. So further, how it is being evaluated, we will see. Okay, so what you have here, so denominator 2 is common and L square is common, that is being taken out. Numerator W is common and 4H is also common. So those will come out of the integration. Okay. So 4W into H common terms, you can see it here. So W is common term here and here. So W will come out of the integration. 4H will also come out. 2 here, 2. So 2 is common. L square. So 4HW by 2L square. So that will come out of the integration. Okay. So this term is constant. Then what is there inside? Lx minus L square. So this Lx minus x square. Then x into L minus x, which is nothing but x into L minus x square. Okay. Right. So it is of same, right? It is of whole square, you can write it. This two terms are similar. Lx here, Lx minus x square. It's whole square of nature. So Lx minus x square whole square, you expand that. So L square x square, first term a square plus b square, so x square whole square. Okay. So a square plus b square minus 2ab. 2 times L minus x into x square. So 2 times L into x square. So Lx cube dx. So L square x square integration x cube by 3 limits 0 to L. Okay. X power 4 integration x power 5 by 5 0 to L. 2L is constant. X cube integration x power 4 by 4 0 to L. So L square into upper limit, if you substitute L here, it will be L cube into L square L power 5. Similarly, L if you substitute here, L power 5, that also common. Same way, L if you substitute here, L power 4 into L power 5 outside the braces. Okay, so in all the cases, you have L power 5 coming out. Lower limit is 0, so you don't worry about substituting lower limit. So what is remaining then? 1 by 3, 1 by 5, 2 times 1 by 4, that means 1 by 2. Okay, so 1 by 3 plus 1 by 5 minus 1 by 2. So you can go for LCM. 30 will work out as LCM. So 3 tenths plus 5 sixes minus 2 15s. I take 2 here. Okay. So 2 15s is 30. So what is now 16 minus 15? What you have is 1 by 30 is the value in the braces. So what you have outside the braces? 2 in the numerator. So 2 into 1 by 30 is 1 by 15. So WH into L square L power 5. So L cube remains. So WH L cube by 15 is numerator value. Okay. Coming to denominator, I don't know whether you remember or not, that last session, we have concluded that if it is parabolic, denominator value will not change. You have to reproduce the same derivation of denominator as discussed in the earlier session. Okay, no change. Because y never change, 4hx into L minus x by L square for a parabola whole square. Okay, so this evaluation is discussed in detail in the last session. Okay, so same you reproduce, and that will be 8LH square by 15. That will never change. Okay, for a parabola. So now you substitute for numerator WHL cube by 15, where numerator will have load term involved, whereas denominator will have only geometric quantity. So if you can cancel out all the terms which are similar in the numerator and denominator, what you have, you see WL square by 8H. Okay, it is easy to remember. WL square by 8 is the maximum bending moment for a case of beam with UDL at center, and divided by the rise value H. Okay, so this is the horizontal reaction in case of a parabolic two hinged arch having UDL on its total horizontal span. Okay, so if you have a parabolic arch of two hinged arch with UDL on its horizontal span, the horizontal reaction or horizontal thrust is WL square by 8H. Okay, so WL square by 8H, to remember it is very easy, as you have bending moment for a similar case of beam with same span, same load. It is WL square by 8 is the maximum load. Okay, so this is how we evaluate a parabolic two hinged parabolic arch with UDL uh, as a case of it is an example, but also appeared in the JNTUK in 17 November examinations. Okay, right. Thank you so much.